Hi, this is Alex from devstories.eu. Apache Cassandra with Python, Episode 4 of 12. Connect to a traditional database and you point your application at a single host address. Connect to a distributed database and you might assume you have to manually track dozens of server addresses in your configuration files. You do not, because your database driver actually acts as a smart router. Today, we look at connecting with Python. Consider a Python microservice booting up. It needs to establish communication with a local 3-node Cassandra cluster. To begin, you bring in the cluster class from the Cassandra.cluster module. You initialize this class by passing it a list of IP addresses known as contact points. If your nodes use a non-standard port, you can also specify a port argument here. Otherwise, it defaults to 9042. Developers often confuse this step with building a standard single DSN connection string, where you must explicitly list exactly what you want to talk to. With Cassandra, you do not need to list every single node in your infrastructure. If you have a massive 30-node cluster, passing just 2 or 3 IP addresses as contact points is perfectly fine. Here is the key insight. When the Python driver starts, it reaches out to one of those contact points to bootstrap itself. It queries system tables to download the current cluster topology. By doing this, it automatically discovers the IP addresses of the rest of the nodes. The driver dynamically maintains this network map in the background. If you scale out and add nodes later, the driver detects the change and adjusts its routing automatically without requiring an application restart. Once you instantiate your cluster object with those initial contact points, you call its connect method. This action returns a session object. The session handles the actual connection pooling to the nodes it just discovered. When calling connect, you can optionally pass a key space name. A key space functions as a namespace for your data. If provided, the driver sets it as the default for all future operations on that session. Because the session manages complex connection pools under the hood, it is designed to be long-lived and thread-safe. You typically create one session at application startup and reuse it. Now, the second piece of this is connecting to a managed cloud service like DataStax Astra. Astra operates differently and does not expose raw IP addresses for contact points. Instead, you download a Secure Connect bundle. This is a zip file containing the required certificates and mutual TLS connection details. In your Python code, you skip the list of IP addresses. Instead, you provide a cloud configuration dictionary to the cluster object. This dictionary contains a key called Secure Connect bundle, which points to the local file path of your zip file. You combine this with a plain text authentication provider object configured with your client ID and secret. Calling connect then yields a standard session object, functioning exactly like the local cluster setup. The critical takeaway is that whether you pass a few local IP addresses or a cloud secure bundle, the Python driver takes your initial entry point, maps the distributed network map, and entirely abstracts the routing logic away from your application code. That's all for this one. Thanks for listening and keep building.